Hello everyone. Today I will be demonstrating how to implement internationalization in Spring Boot with dynamic content without storing translated data into a database. For this we will be using Smart i18 and auto dependency, which is developed by me, which you can access from Maven Central. The link will be in the description. First, we have created a Spring Boot project. Now start with the database configuration, URL and other few important things. I have database URL in my environment variable, so I can fetch it over here directly from there. In this, we will be using a Hibernate for the ORM purposes. This will help us to see what SQL queries has been triggered by the ORM. Now let's add our dependency for internationalization and perform required configuration. So let's go on a Maven Central, which is another way is Maven repositories. I will add the link in the description to get the dependency directly. We will be using the latest version. Copy it to clipboard. We'll go in a pom.xml file and add the dependency in the dependencies section. Now as we save, it will automatically be downloaded. Once it is downloaded, now we can start the configuration. So first we have to enable this by smart i18 and smart.i18 and dot enabled equal to true. Next we will be declaring the default source local language, which will be the default language from which we will be translating. You can skip this part if there is no default language you have. It will automatically be detected by the dependency. Next we will add the API key. Over here I am using Google Translation API key, so I will add spring.i18.google cloud API key and I will add my API key over here. Again I have it in my environments. You can add it over here. Next we will be displaying the logs. For that we need to go with logging level.in.tamakuwala i18 dev.tamakuwala dot smart i18 auto, and the value will be debug. This will help us in logging. Next we will add the timeout in milliseconds from the provider side. Provider dot timeout in milliseconds. Over here I am adding 3000, which is 3 seconds with the timeout. Next we will be adding a cache maximum time. Over here I am going with the 12 hours, which is 720 minutes. Over here we have to provide this in a minutes format. Over here the provider will be detected by itself. If you don't want this, you can also declare by yourself by adding this one configuration, which is smart.i18 and dot provider.active equal to, this is default like Google Cloud. Now first we will run our application to see if there is any kind of error or something. So as you can see, there is no error. Yeah, and our server is started successfully. Now we will move ahead and we will start creating our packages and other main content. Now let's start by creating packages which we will be required. So over here we will be using the clean architecture, which is model controller repository architecture, also service layer. So let's create the package for controller. Next we will be creating a package for model. Next we have repository. So now let's create the last one, which is service. Now let's start creating our models. So over here we are using the example of blogs. So we will be using only one model, which is blog model. Over here we will be declaring it as an entity for the ORM purposes. Next, we will be declaring the table name. If you don't want to declare it, you can skip it. The ORM, it will assign the name by itself. But over here I want to have my own name, so I am declaring it as tbl blogs. We have to import it and import table from Jakarta persistent table. Next thing is the fields. So over here we want ID, title, summary, content, and created date. So over here let's start by ID, which will be private integer ID, and we will be declaring it as ID, and the value will be generated value. Strategy will be identity. Generation type dot identity. Next one is title. Another one is summary. Next is content, which will be the main content of our blogs. And the last one is created at date time. So over here I will be using local date time. You can use whatever you want. Over here I will be declaring the length of the content section as 3600 characters, because it will be the long one. By default the length is smaller, so we cannot add much things, so we have to change the length and extend it to what we require. Over here I am going with 3600, which is good enough for my project. Next, we will be creating a few constructors and getters and setters. So first let's start with the constructor, all fields constructor. Next we will go with the no field constructor. Next we'll create all getters and setters and generate. Next, if you want, you can also create the toString methods. To get this shortcut, you can go with Shift Alt S, and you can have this pop up so that you can find whatever you want. Now the blog model is done. Next we will be creating a repository, and the repository will be our interface. Done. Now we will annotate it as a repository. You can skip this if you don't want to declare it. It works as well. And we will extend it with JPA repository. So the CRUD operations will be managed by the JPA itself. The return type will be blog model, and its ID is of type integer. And that's it. The repository is done. If you want to have any custom queries, so you can add it over here. Now let's go and create our controllers. There will be only one controller, which will be a block controller, and in this controller we will be adding all other things. We will declare it as a REST controller, because we are not sending any resources as a response, we are only sending the data. So we will annotate it as a REST controller. Next, we will declare it with the request mapping, because I want to have a unique I want to have a serial API URL, so it will be /API. Next, we will create a endpoint to get all the blogs, and to get all the blogs we will create a get mapping with /blog as the URL /blogs. This will be a public. As of now I am just creating a normal one, so we'll first return a normal string and we'll test it if it is working properly or not. It will be string get blogs, and we will return hello world. Now the server has started, so let's go in a postman and we will fetch it if it is working properly or not. So over here we will call localhost colon 8080 /API/blogs. If we hit the request, we are getting hello world. Now this is the normal response which we have written over here, but what if now we want to convert it in a different language? So let's first configure that. To auto translating any controller or any field, we need to annotate them with this annotation, which is auto translate, which is from the smart.in.devtamakwala.smart i18n auto annotation translation, and it is done. Now we only need to send a header which is accept language, and we can send any language, like if we want to test it in a Hindi. So server is started and accept language which is Hindi, and send. As you can see, we got the response in Hindi now. If we want to change it, so easily we can change it to any other language, like let's say Kannada. So we send KA and send. The language is changed. Now we will create the service layer to fetch the data from the repository. Repository will talk to our database, and we get the response from the table. So new class, it will be block service. Now over here, what we will be doing is we will annotate it as a service class because it is a service. Over here, we will fetch the object of blog repository from the IOC, which we will do auto wired as private blog repository. Blog repository. It's done. Now we'll create the method to extract all the blogs from the database. So for that, we will be creating a public. It is a list of blog model because there might be multiple blogs. So list of blog model. Next is no fetch all. We will name it as fetch all blogs, and what we will return is return repository dot find all. This is done. Now the ORM itself will fetch all the blogs and it will be returned. Now we will import these things, and it's done. Now we will connect our service layer with the controller. So we'll create it will be as blog service, Now we will be changing its return type from string to list blog model because it's a list of blog models, and we will go for blog service dot fetch all blogs, and it's done. Now the server is getting restarted. Server is restarted. Now we will check if there is any blog available or not. First we will fetch the blogs in a normal language which is there in the database. So let's send. Yeah, so these blogs are available in the database. So we got it in the English language because we have not implemented any other language as a requested. Now we want to have all these blogs in a different language, let's say for Hindi. So I'll add this header and change from KA to HI, and let's send. It will take some time because it is translating all the blogs real time. So it took about 4.4 seconds, and we got all the blogs over here. It will not translate the numeric numbers. As you can see, the IDs are still same and the dates are still same. Now also this dependency has inbuilt caching layer. So if you call the same blog again, I mean with the same language again, it will take less time. So over here, as you can see, it took 4.4 seconds. Now we'll hit it again. So you can see the difference. Now it got only 303 seconds, milliseconds. Now let's again call it in another language, which is KA, Kannada, whatever it is. It is taking a little bit more, and you can see again the language is changed. So this way we can translate our blogs dynamically from the database. I don't have any translated blogs in my database, but I can get the translated blogs and the API call. Now if you want to not to translate any particular field, we can also do that. For that, we just need to go in a model or wherever we want to skip the translation. In this, we will take an example of a title. Like I don't want to translate the title, I want it as it is in the database. So let's go ahead. In the model, just before the title, we will add one more annotation called skip translation. Skip translation added. Now let's wait for the server to restart, and the server is restarted. Now again, let's first let's fetch the data in Hindi. So send. It take 3.94 seconds. and as you can see, all the titles are in English only. So titles are skipped in a translation because we added that one particular annotation of a skip translation over the title. So this way you can skip the field from getting translated, and you can get rest the data to rest all the data will be translated. Now I have created a demo website for this, which is i18n webdemo.devtamakola.in. You can go on this website and try it out by yourself as well. I have deployed this. You will also get the detailed documentation about this on my website. I will also share the website link in the description. You can check all these things and you can explore many more things. I have added so many things in this. You can go and check it out by yourself as well. It's pretty big dependency. I cannot add everything in this one video. So I have added the most important things, which is to translate the data automatically. I will add this website link in the description as well, so you can check it out. If I talk about real world example of this dependency, so it can be an e-commerce platform which serves in multiple region, in multiple countries. They can easily translate product details, product description, and other things with single API only. They don't need to create and maintain a separate database or separate files just to have a new translation. Another big example is government website. If we talk about India, has so many languages, and these languages are based on regions. If a user is accessing a website from a certain region, then we can send the response in their native language. This will help the user to interact with the website more. It will affect the UX so much. Another big example is the banking sector, meaning there are so many banking there are so many messages or alerts that the bank sends to user which are very crucial, like bank OTPs, transaction alerts, error alerts, and many more. If user is not able to understand English every time, this can be a big problem for the customers. So banks can use this particular feature and implement internationalization with just a plug and play dependency. They don't need to create a separate file or use any big tools to convert their messages into the native language. They just need to insert one simple dependency, and it will be done by sending a response. So these are few big examples which where this dependency can be very much useful. I hope you like this video. If you have any doubts, feel free to ask in comment, or you can connect with me personally. Contact details are in description. Thank you for watching video.